So hello everyone and welcome to the new section of our tutorial. In this tutorial I will be discussing about the assembly. So let's just start. So we will learn it by doing a project. So I'll be explaining tool and using them all together. So there is an assembly, you select the assembly. So when you select the assembly, it will ask for the parts which with you will do the assembly. So I select all of the parts which I will use. So it will ask you to place them. I am placing them wherever, at a random place. So I can just wait around here. So we just okay, right now the final product that we will do will something look like this. So we have all the parts. Now what we want to do, we want to assemble them into a single product. So these are our different product parts. Now assembly is very important because it gives you the whole product with and you can also define the constraints and everything. So let's just start with basics. So first of all, you can move your components from here or rotate. So let's just select move and you can click on it and move anything that you want, but I cannot move this one. So what I can do is just right click here and click here float. Okay, it's let me check. Okay, it's already moving. Now anything that doesn't move, you can just set the option. So if you want to fix this one, you just right click and fix, so it will not move. Now let's just work according to this image. So in this image you can see these two are aligned. Their center is same, so they has to be concentric and they are touching each other. So so we can start from there. So yes, so let's start. So first of all, I will do in sketches we have discussed the relations, right, to define the relationship between the different sketches and also to limit them. So in assembly we define the mates for the same purpose, to give them a limitation in their movement. So for example, there is a concentric mate. So for the concentric mate you have to select a cylindrical surface or a circular edge. So I am selecting the surface. I am also selecting the surface here. So as soon as I do that, you can see both are aligned in the same you can say same. Now they have the same axis of center. So you can also lock the rotation, otherwise just click out of it. Now when you go to move here, you cannot, it will always stay in this axis. It can rotate, even it can move along, but it will all their axis of center will remain same. So this is what is happening. Now they both are connected in a way that this side has to be the other side. The planar sides are touching each other. So we can achieve it easily by using mate. Go to mate and select here coincident, this surface and this surface. Now both of them are coincident, but we do not want it this way. So you can just click here, it will opposite it. Now this is what I want. You just select OK. Now if you try to move it, it will not move because this is in the center. Their center is same and it is coincident to this one. Now this system is fixed. Now there are different mates. You can see the parallel mate, perpendicular, tangent even. So let me just tell you about other mates. So the next thing that we have to do is to put this key in this let's call it lock. So we have to put this key in this lock. So we can try coincident easily, it can work. Now there is I think I should go along with okay, let's try something. I have another in advanced mates. I will use one advanced mate here. The advanced mate is the width, so I can use width here. So before using width, let's use parallel here. So I want this face and this face to be parallel of each other. So you can see right now they are parallel, but it is so they are parallel. Now I can just click here and or I can make them coincident. So basically it is a coincident, so I will leave it to the coincident. And okay, now let's exit and try to move our component here. And yes, it is moved. Now next thing is to actually coincident this thing here. Now we can just go to mate and coincident here. Where is, yes, this is the coincident. You select the bottom surface of this one and I can select this one. Now it is coincident on this. Okay, so the next thing is that we want this key to be in the center of this lock. So we can do this by defining the distance here. We can turn on the distance and we can select these edges and we can lock it easily. So we can decrease the value whatever we want, like 0.001 or something like that. And I can see it. So we'll have to measure the distance that we want, then we can apply. Now, so once we fix that, another way is, if you think, if our calculation says that this key is in the center, you can just click it and lock it. So you can select both and just you can lock it, so it will not move. So both of will act as a single entity. So we are done with the lock. So we can apply our lock. So the lock will be applied here in the center. Now you can see we have to rotate it because both of these has to be aligned. So let's just work along with. So we can apply the parallel between this plane and this plane to make it in the same direction. So select this one, and you can see it has done rotating. And yes, coincident will also work. Just click on it and it is done. Now the next thing is to put this key in this here. Now okay, let's first make this plane and this plane parallel. Okay, now it is applied. Now the next thing that we want is to make it concentric, the center of this cylinder, and this one has to be same. So we select the concentric. Let's just select the edge, and in this case even the surface, so it is selected. Now you can say the key is applied, but the thing is the key has to be in the center. You know, if you look at this, sorry, not the key. So this part has to be in the center, the lock has to be in center. For example, this is actually touching this, and here we see there is a certain depth, so we have to keep the lock in center. To do that, we have another mate. So we can go to advanced mate and select the width. So in width, what it does a great help in centering purposes. So what I do, I just select this plane as a width, this and this one, and these two as a tab, and it will center it. And you can see it does a little shift and it is in center. So you can also do other things, but it is really good for the center purpose. Now you can see it is in center. And now the next thing is to apply these nuts and bolts. So it is gonna be easy. So first of all, we will go to the standard mates, and for example, and this assembly also has some intelligent system. It also detect automatically that what we want. You just, for example, if you just click on this surface and this one, it will automatically understand that we want to apply the concentric here, and we also want to touch this edge on this surface. So we can just click on the edge and click on the surface and it will touch it. So you can see most of the things are automatic. Now next is to apply this one to here. Now I can again click on the concentric and click here, so it is applied. Click done. Now next thing I want is to touch. Okay, so we can take the help of cross-section view here. So okay, let's come outside and select the cross-section view. Okay, I will do a little rotation right down here. Okay, this might work. Now I come here. So I select the mate as this is the bottommost point of the, and this is the bottom. So it has moved. When I get out of the cross-section view, you will see the work has been done. Now you can see there are 4 more holes, so you have option that you can import again those files and apply those screws here. Otherwise you can do is you can just use the linear component, go to circular pattern here, and you can select the component to pattern. I want to apply this nut and this bolt. You can select the direction. I want this direction. Now there are actually 4 quantities. Apply equal spacing, and you can see it has been applied. So you can see this work it is completed. So basically it is done, and we can check using the movements if there is something like. Now you can see it is still rotating. That's why we see underdefined here in the bottom. So we can also log the rotation, but for the time being it doesn't challenge anything. So if you want to lock it, so you can either just click here and select the body and you can go for the lock. Now let's cover another example which has other assembly properties. Mates. So just import our files here. So I'll be using just these 2 as my files. For example, I import this guy and this one. So I need 2 of them, so I can make a copy, or I just import them again. So I'm importing them here. So let's just quickly do some mates here. So not again. So I'm gonna apply this concentric mate between these 2. Then concentric mate between these 2. The planar surf. Not, I want to apply the parallel here, and I also want to apply parallel here. Then I want to actually move this apart, something like here, so it can work. And I also move this one. Then go here, move Okay, so just right click here and select float, then also move it. Now let me fix few more things. So I am fixing this one in parallel with this surface. Okay, now what I want to do, we are going to see the one of the advancement that is called the linear coupler mate. So let me just show you. So for example, if I am just moving this and I am moving this one, so if we are working in assembly where we want to define a system where if I move this for like a 1 meter, then they should move for 2 meters. Okay, so we can achieve that using the linear coupler mate. So we can just go to the mate and advanced mate and select the linear coupler, and you just select the planes which will be actually going to be moving, and you can just define the ratio, like I defined the 2:1. So if one of them move, now their movement is now synchronized. So for example, if I move this one, you can see it just have gone half and it has completed the whole. So this is how you can apply the linear coupler mate. So this is pretty much useful in machines like in the assembly of 3D printer. Now let's discuss so the next thing that we are going to discuss is the Pathmate. So I'll be importing this assembly file. Now let's just look into it, how we're going to do it. So Pathmate is used when you have a particular part that is part 5 in my case, and you want to make it follow a particular path, that is part 4 here. So that's when we use the Pathmate, and it is used in uh, things like 3D printer or everything. So that can be super useful to you. Go to Advanced Mate, select the Pathmate. Now it requires a vertex, and vertex has to be the part of that model which will move. So here in this model I didn't find any vertex, so what I did, I just added a point here using the sketch. So you can also do that. So we just go to, so we can apply the path using easily by just going to Advanced Mate and going to the Pathmate. So this is our part 5, so I select sketch 3, which is our component vertex. For example, this one, when I select this as a path, now it says that please select path and the vertex from a different. So for the time being, what I can do, I can hide this sketch, so it is hidden. Now I select the vertex from the model. Now then for the path selection, I can again come here and select this one. I can make it visible and select this for the path. Now it's working. Now just click here. Now you can see there are a few more controls like pitch and yaw control. First, let's just do it and randomly, and when you try to move it, look, it is rotating randomly and but following the path. So this is about the Pathmate. And in the assembly, so I have covered the standard mates, coincident, parallel, and these things, and will also covered the advanced mates. So mechanical mates are quite like advanced, so I'm not covering them in this tutorial. So this is so we have covered till now sketch, features, and assembly. And if you want to learn these things by the projects, you can go to our other playlists and you can learn from there. So see you in the next sections.